Welcome to emstatonline. Today we are going to see Chebyshev inequality. Basically, this one under bounds of probability. If we know the probability distribution of a random variable x, we may compute E of x and variance of x. Conversely, if E of x and variance of x are known, we cannot construct the probability distribution of x and hence compute quantity of x minus mu, which is less than or equal to k. Although we cannot evaluate such probabilities from a knowledge of expectation of x and variance of x, but several approximation techniques have been developed to yield upper bound and lower bound to such probabilities. The most important of such techniques is Chebyshev inequality. Let the random variable x has mean mu and finite variance sigma squared. Then for any epsilon greater than 0, a fixed number, the chance that x differ by at least epsilon from its mean is bounded. That is, probability of x minus mu is greater than or equal to epsilon, which is less than or equal to sigma squared by epsilon squared. Chebyshev inequality shows that the probability that x is outside an arbitrary interval mu minus epsilon or mu plus epsilon is negligible if the ratio sigma by epsilon is sufficiently small. If standard deviation is equal to 0, then the probability that x is outside the interval mu minus epsilon and mu plus epsilon is equal to 0 for any epsilon. When we are going to use Chebyshev inequality, the probability of an event described by a random variable, its distribution or density is required. If the distribution or density function of a random variable is not given, but its mean and variance are given, in this case we can use Chebyshev inequality. A proof: if x is a random variable with E of x equal to mu and variance of x equal to sigma squared, then probability of modulus of x minus mu greater than or equal to c or epsilon, which is less than or equal to sigma squared by c squared, where c is greater than 0. Let x be a continuous random variable with a probability density function of f of x. Then sigma squared is equal to minus infinity to plus infinity x minus mu the whole squared into f of x dx. But this one we can write integral minus infinity to mu minus c x minus mu the whole squared into f of x dx, mu minus c into mu plus c x minus mu the whole squared into f of x dx, and mu plus c to infinity x minus mu the whole squared into f of x dx. It's a continuous function. So minus infinity to plus infinity we can write minus infinity to mu minus c to mu plus c to infinity. So this one we can write which is greater than or equal to integral minus infinity to mu minus c mu x minus mu the whole squared into f of x dx plus integral mu plus c to infinity x minus mu f of x dx. And definitely this one is greater than or equal to. How? This 3 integral minus infinity to mu minus c to mu plus c to infinity. But here we write mu minus c to mu plus c, eliminate this one. Here we write only 2 cases. So definitely this one is greater than or equal to. Sometimes this value is equal to 0 means is equal to. Suppose this value is more than 0, this is greater than. That's why we are writing greater than or equal to. So according to the definition of probability of capital X is equal to x, or capital X is less than or equal to x case, minus infinity to mu minus c. So first interval x is less than or equal to mu minus c. This interval x is greater than or equal to mu plus c. So from this case x minus mu less than or equal to minus c, x minus mu greater than or equal to c. Now squaring on both sides, x minus mu the whole squared is greater than or equal to c squared. Here x minus mu the whole squared is greater than or equal to c squared. So sigma squared is greater than or equal to c squared integral minus infinity to mu minus c into, this one is greater than or equal to c squared, so we can write c squared into f of x dx plus integral mu plus c to infinity c squared into f of x dx. C squared is common for both integral, so we can write c squared into integral minus infinity to mu minus c f of x dx plus integral mu plus c to infinity f of x dx. This case. So which is greater than or equal to c squared. So probability of x is less than or equal to mu minus c plus probability of x is greater than or equal to mu plus c. So which is greater than or equal to c squared. This one we can write probability of mu minus c greater than or equal to x greater than or equal to mu plus c. C squared. This one we can write probability of minus c greater than or equal to x minus mu. This case c. So that is equal to, so greater than or equal to c squared into probability of x minus mu greater than or equal to c. So probability of, from this probability of x minus mu greater than or equal to c, which is less than or equal to sigma squared by c squared, because this is here sigma squared. Or probability of x minus mu is suppose less than c, which is greater than or equal to 1 minus sigma squared by c squared, where c is greater than 0 in this case. Basically, the Chebysheff inequality come from Variance inequalities. Let us assume n is equal to 2, we can get this Chebysheff inequality. Now we are going to see the problems. A random variable x has a mean, let us assume mu equal to 8, and variance sigma square equal to 9, and unknown probability distribution find probability of minus 4 less than x less than 20. And probability of x minus 8 is greater than or equal to 6. So according to the problem, a random variable x has a mean given, variance given, and the probability distribution function we don't know. They ask some interval value. So in this case, we use Chebysheff inequalities. Solution: mu equal to 8, sigma squared equal to 9, so sigma equal to 3. So probability of minus 4 less than or equal to x less than or equal to 20. So this case, general form mu minus epsilon to sigma less than x less than mu plus epsilon sigma. The probability in the form of mu minus epsilon sigma epsilon less than x less than mu plus sigma x. So mu minus epsilon sigma equal to minus 4. Mu given and epsilon sigma given equal to minus 4. So 8 plus 4 equal to 3 epsilon. So 12 equal to 3 epsilon, epsilon equal to 4. So probability of mu, that is 8 minus 4 into 3 epsilon less than x less than mu plus 4 into 3. So which is greater than or equal to 1 minus 1 by 4 square. That is equal to 15 by 16. So probability of minus 4 less than x less than 20, which is greater than or equal to 15 by 16. Second one, probability of modulus of x minus 8, which is greater than or equal to 6. So definitely less than or equal to 9 by 6 squared. Since probability of x minus mu is greater than or equal to epsilon, which is less than or equal to sigma squared by epsilon. Use this one, we get 9 by 16. Okay. A random variable x has a mean 10, a variance 4, and an unknown probability distribution find the value of C such that probability of x minus 10, which is greater than or equal to C, which is less than or equal to 0.04. What is this meaning? Just find the value of C. Here unknown probability distribution, mean and variance given. So use Chebyshev inequality. But according to this one, probability of x minus mu, which is greater than or equal to epsilon, which is less than or equal to sigma squared by epsilon squared. Variance given, mean given. So sigma squared by epsilon squared is equal to 0.04. So epsilon squared is equal to, from this one, epsilon squared equal to sigma squared by 0.04. Sigma squared, we know that 4 given. That value is 100. So epsilon is 10. So epsilon is 10. Here they use C. So C is equal to 10. So the last problem, mean variance given, an unknown probability distribution. Just find out the value of modulus of x minus mu. So in this case, they want to find epsilon from the given data. Another problem. For a geometric distribution, f of x equal to 2 power minus x, for x equal to 1, 2, 3 and etc. Show that probability of x minus 2 is less than or equal to 2, which is greater than 1 by 2. But here distribution given, f of x equal to 2 power minus x given, show that x minus mu less than or equal to epsilon, which is greater than or equal to sigma squared by epsilon squared. So they want to prove this one. Basically, we know that probability distribution is unknown, mean and variance given. From mean and variance, we can find out the probability of modulus of x minus mu greater than or equal to sigma and less than or equal to 1 minus sigma squared by epsilon squared. But in this problem, distribution is given, geometric distribution, mean and variance not given. But the probability of x minus mu less than or equal to 2, which is greater than or equal to 1 by 2. Obviously, it is a Chebyshev inequality. Solution. So we need mean and variance. So mean expectation of x. It's a discrete distribution. So x equal to 1 to infinity x into f of x. That is equal to summation of 1 to infinity x into f of x is 2 power minus x. So we can write 2 power x. So put x equal to 1 by 2 plus 2 by 2 squared plus 3 by 2 cube and etc. This one we can 1 by 2 will be taking outside 1 plus 2 into 1 by 2, 2 into 1 by 2 plus 3 into 1 by 2 squared and etc. So this one 1 by 2, 1 minus 1 by 2 the whole power minus 2, because 3x squared, 4x cube and etc. 1 plus 2x plus 3x squared plus 4x, and so 1 minus x the whole power minus 2. So 1 by 2, 1 minus half power minus 2. That is equal to 2. Since 1 minus x the whole power minus 2, that is equal to 1 plus 2s plus 3x squared plus and etc. Use this formula. Similarly, you have to find out variance. Variance e of x squared minus e of x the whole square. So we need to find e of x squared also. So summation of 1 to infinity x squared into f of x. That is equal to summation of x squared by 2x 1 to infinity. So 1 by 2 plus 4 by 2 squared plus 9 by 2 cube and etc. So here also 1 by 2 will be taking outside. 1 by 2 will be taking outside. So 1 plus 4 into 1 by 2 plus 9 into 1 by 2 squared and etc. So this one we can write 1 by 2, 1 plus half, 1 minus half whole power minus 3. So this value 1 plus half, 1 minus half the whole power, this one minus 3. So 6. Because 1 plus 4x plus 9x squared plus 16x cube plus etc. is equal to 1 plus x into 1 minus x the whole power minus 3. Use this one, we can write. So e of x squared is 6. Already we know that variance of x equal to e of x squared minus e of x the whole square. So 6 minus, that value is 2, 2 squared So variance is 2. So sigma is square root of 2. Therefore sigma is square root of 2. By Chebyshev inequality, probability of x minus mu, which is less than or equal to k sigma, which is greater than 1 minus 1 by k squared. So probability of x minus 2 is less than or equal to 2. We can write probability of x minus 2 is less than or equal to 2. We can write square root of 2 into square root of. Since sigma is square root of 2, so which is greater than or equal to 1 minus 1 by 2, that is equal to half. So probability of x minus 2, which is less than or equal to 2, is greater than 1 by 2. So in this problem, geometric distribution given, but mean and variance not given. So actual probability is probability of x minus 2 less than or equal to 2, which is equal to probability of 0 less than or equal to x less than or equal to 4. So x equal to 1, 2, 3, probability of x equal to 1, 2, 3 or 4, 0 to 4. So 1 by 2 plus 1 by 2 squared plus 1 by 2 cube plus 1 by 2 power 4. That is equal to 15 by 16. So this is the actual probability of the given function f of x. So first type, mean and variance given, unknown distribution. The second type, mean and variance given, just find the value of c. The third type, distribution given, mean and variance not given, even though that interval value they want asked. And sometimes if x is the number of, if x is the number on a die, when is thrown, prove that probability of x minus mu, which is greater than 2.5, which is less than 0.47, and mean, the mean of x, mu is the mean of x. But in this case, x is the number on a die. So definitely number 1, 2, 3, 4, 5 and 6 with the probability 6. So x tends to number on a die. So its values 1, 2, 3, 4, 5 and 6 with probability 1 by 6. Why we need to put this one means we need mean and variance. So it's a discrete case. So x equal to 1, 2, 3, 4, 5, 6. So p of x 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6 and 1 by 6. So e of x, x into p of x. E of x equal to summation of x into p of x. That is equal to p of x is 1 by 6. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. That is equal to, n into n plus 1. So 1 by 6 n into n plus 1 by 2. That answer is 7 by 2. So similarly we can find variance. So we need to find e of x squared, summation of x squared into p of x. So 1 by 6 same we take outside, 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. That is 1 by 6 n into n plus 1, n into n plus 1 into 2n plus 1, the whole divided by 6. That answer 91 by 6. So just find the variance. E of x squared minus e of x the whole square. That is equal to 91 by 6 minus 79 by 4. That is 7 by 2. Use calculator 167. So by Chebyshev inequality, probability of x minus mu, which is greater than epsilon, which is less than sigma squared by epsilon squared. So now probability of x minus mu, which is greater than 2.5, which is less than that value 2. Sigma squared 2.167 by epsilon squared 2.5 the whole square, because epsilon given in the problem. So answer 0.47. So probability of x minus mu, which is greater than 2.5, is less than 0.47. So here the types are unknown probability, mean variance given, and find probability of x minus mu, which is less than or equal to or greater than or equal to case. And another type, just find out the value of epsilon. Another type, geometric distribution given, just find mean variance and probability of x minus mu is greater than c. If another type, discrete distribution given, just find mean value and just find the value of probability of x minus mu greater than or equal to sigma. Basically example number 5. Fair die is tossed 720 times. Use Chebyshev inequality to find a lower bound for the probability of getting 100 to 146. So xp, the solution, let x be the number of 6 obtained when a fair die is tossed 720 times. So probability of getting 6 in a single thrown, probability of getting 6 in a single case, a single toss, 1 by 6. So we know that Q equal to 5 by 6, N equal to 720. So X follows a binomial distribution with mean NP and variance NPQ. So X follows a binomial distribution with mean NP, so N is equal to 720 P, so NP 120, and variance NPQ, so this value is 100. So mu 120, sigma squared 100, so mu 120, sigma squared is 100, so sigma is equal to 10. By use Chebyshev inequality, x minus mu, which is less than or equal to k sigma, which is greater than or equal to 1 minus 1 by k squared. So probability of x minus 120 is less than or equal to 10k, which is greater than or equal to 1 minus 1 by k squared. So probability of 120 minus 10k less than or equal to x less than or equal to 120 plus 10k, which is greater than or equal to 1 minus 1 by k squared. When k is equal to 2, we get probability of 100 less than or equal to x less than or equal to 140. So this is our question, which is greater than or equal to 1 minus 1 by 2 squared, 4. So that is 3 by 4. Therefore, required lower bound for the probability is 3 by 4 or 0.71. So here they ask only lower bound of the probability. So we can use the lower bound form, we can get the value.